Let's now look at logical volume management. This is a means of being able to aggregate storage into storage sets for simple management, which allows you to extend, resize, reduce, as well as allocate storage on the fly. So logical volume management, or via its acronym LVM, and there are numerous features, of course, including the ability to create volume sets, resize storage on the fly, which means hot without having to reboot the system, and provision storage as necessary. So provision storage as necessary. The volume set feature is the most important because it allows us to aggregate. So aggregate storage from disparate sources. That means you could have SATA, IDE, SCSI, iSCSI, you name it. So long as the kernel is able to see the storage, you can allocate it into a volume set. Of course, there are inherent weaknesses in the argument of spreading storage across the network as well as locally and so on with respect to things going awry, but nonetheless LVM will allow you to aggregate storage wherever it's available on the system without regard for storage type. It does this by creating a hierarchy which represents the LVM storage tree. So what we'll do is start talking about these things, including the LVM storage hierarchy. So before creating anything LVM related, it's important to understand how the hierarchy works. The most basic object in the hierarchy is a physical disk or a physical volume. Physical volumes are aggregated into volume groups, and from which we create logical volumes that we store data on. So there are a number of ways in which you may look at it. A logical volume is where you configure the file system. So configure file system at this level. But in order to make a logical volume, you need to have first created a volume group. And a volume group represents one or more physical disks or volumes. We say volumes because you can aggregate partitions from one or more disks. So a physical volume may not necessarily be the same as a physical disk, although it should be for performance reasons. And then beneath the volume group you've got physical volumes. And these are, for example, like dev SD B4, which we've yet to create it, dev SD C3, etc. So they may be partitions. You partition them using fdisk or parted. And in particular, you set them to LVM type 8E as opposed to Linux type 83, on which we overlay ext file systems, or 82 for swap. So first we need partitions that are set to type 8E. We then arrange those partitions into volume groups. That's where the aggregation takes place. Once you have a volume group, you then abstract logical volumes from those volume groups. You could, for example, create one logical volume which represents the entire storage presented by the volume group, or n number of logical volumes that represent n number of partitions or sections of a volume group. So it's a three-tier hierarchy: physical volumes, partitions, volume groups, and then logical volumes on which we overlay file systems. So how do we create this hierarchy? Create LVM storage hierarchy. And we've outlined 6 steps. These are 6 common steps, plus or minus 1 or more depending on the methods used. And they include, of course, first creating the partitions of type 8E or type LVM to associate with our logical volumes. So step 1 for us is to create LVM partitions on available disks using either parted or fdisk. So let's see what's available in our system. Left disk L, dev SDB, and dev SDB is currently configured with 3 partitions, 10, 10, and 1 in terms of storage, so 21 gigs are used, leaving 15 gigs available. So we could use, for example, 10 gigs to create our first LVM, or 5 or what have you. It doesn't matter. So using either parted or fdisk, let's go with parted. Parted dev SDB. That focuses on that particular drive. We use makepart to set the partition, its size, etc. And then we can define the type that the partition will be. So let's go ahead and makepart. And we can always, before doing so, just print to see what's there. So it's going to be partition number 4. And its size is going to be, let's say, 5 gigabytes. So makepart primary, and we will start at, let's say, 20 GB to 25 GB. And it says the closest they can give us is 21.1. This is fine. And then let's print to see, and we'll tell it the resulting partition is not properly aligned for best performance. We'll just ignore it. And let's print. Of course, the kernel complains about the addition of the new partition. So from 21, the size is unimportant because we're creating volume sets as opposed to RAID sets that require the same size. So this is one partition that we may have to reboot the system to realize, which is about 4 gigs. And its type is currently not set. If you run help, you'll see that the set option is there to allow you to set a particular partition to a particular type. And if you do a help set, so you don't have to memorize it, you'll see that you can set the partition number that's of interest to any of the types indicated. So, for example, set number 4, and this is going to be to a particular flag, one of which will specify LVM, and the state should be on. Let's print the partition table. So now we see number 4 is set to LVM. So that's our first LVM partition. Now let's select a different disk, dev SDC, print the table, and currently 11 gigs are in use. So let's define a new partition. Let's makepart primary. Could be extended, but for this case we'll go with primary. And we'll start at, let's say, 11.2 GB to, let's say, 16 GB, and it'll adjust as appropriate. In fact, it didn't have a complaint. Let's print, other than the fact that we may have to reboot. And then we should set the type again, help set, and set number 3 to LVM on, then print the table. So now this is another LVM partition. Let's quit. We can use fdisk or parted. Let's list dev SDC. There are the partitions in dev SDB. Now whether or not we'll be able to write to the partition immediately remains to be seen. But to avoid confusion, let's just reboot the box. And it should be back up momentarily, so let's just note, create LVM partitions on available disk. A1 we use parted on dev SDB initially, and within parted we made a partition using makepart. We called it a primary partition, and we put the start and the end, which can be specified in terms of blocks or size or otherwise. And then we set the type using the set option, And each of the options have corresponding help, so you can run those when necessary. So set, for example, and this was partition number to LVM and then on, and then we rebooted because the system did not take, the kernel did not take the changes directly. Again, this will not occur on all systems. It may just happen on this system. It's a slightly older system, so a reboot fixes that. Let's see whether or not the system's back up. We'll send a few packets to it, and it's possibly up. It's up, so let's reconnect and confirm that the partitions have been preserved using Part1, for example. This will enumerate all of the partitions. Here's the third partition on SDC, and here's the fourth partition on SDB. And just note that this fourth primary partition makes it impossible for us to create extended and logical partitions on this disk SDB. So at some point, if we intend to make use of the remaining storage, we'll have to remove one of these primary partitions, perhaps the swap partition, and create the extended partition there to encompass the remaining blocks on the disk. So now LVM seems to be ready to move forward. So we've created the partitions. These are the base partitions that are needed. Now we start to interact with each stage of the hierarchy. We start with the physical volumes. There are a series of tools for each layer of abstraction: physical volume, volume group, and logical volumes. And they're logically labeled, and they're similarly labeled so that you can remember them. PV create allows us to create physical volumes, insofar as LVM is concerned, out of partitions that have been labeled type LVM or type 8E. Simply execute PV create followed by the dev tree location, dev SD, and let's go with SDB, for example. We know we have SDC3 and SDB4. So SDB4 and dev SDC3. You can specify more than one partitions on the same command line as options to PV create, and we'll simply loop through each of them. So this will create physical volumes out of these particular partitions. So creates physical LVM volumes from partitions that have been labeled, of course. And when it's complete, we'll execute PV display to display the various physical volumes that are associated with the LVM configuration, which should include any other physical volumes that have been defined during installation and otherwise. So let's associate these, and notice both were successfully created. PV display will reveal all of the physical volumes. Here's dev SDC3 and dev SDB4. So 4.5 and roughly 3 6/10 gigabytes. So we have roughly 8 gigabytes. And here's dev SDA2, which was constructed during installation. So it is available for usage otherwise. And it appears to be the partition that is associated with the root file system because it's 33 gigabytes. So that was the original physical volume that was associated with the volume group named VG_LinuxCBT_serv1. We can associate our newly created physical volumes with the same volume group or create a new volume group altogether. So we've created these physical volumes. We have 2 that we can aggregate into storage. And supposing we're going to mount maybe /var1 off of these things. So we can create a volume group perhaps dedicated to var if we'd like. So that leads us to the next step, and that is to create a volume group. So this volume group creation command is VG create, just like the physical volume creation command is PV create. So VG create followed by the name of the